welcome everybody to week 18, day 2. So you might have noticed there's a new extra credit assignment available, which is to make a splash screen for these videos of mine. You might have noticed I've been putting placeholder art as the splash screen, the thumbnail for my videos. So if you would like to earn some extra credit, potentially a lot of extra credit, there's a lot of videos, points will be added to your pair programming category for doing splash screens. The more you do, the more points you get. And student just sent something. Who is this? Benninghoven. I like that. I like that. There you go. I find that amusing, I guess. I don't know. So something like that, I guess. Nothing too clickbaity though. Like, this is fine. I'm doing the, So.
Yes, by the way, for the people speaking English, it is called a thumbnail.
A thumbnail, splash screen, same thing. Yeah. All right. So Muya did the review yesterday. That's been posted onto YouTube. So anybody who couldn't make it should be able to watch the review with him. The password's in the video, right? Muya? Somewhere?
Yes.
Okay. Yeah, and so on Canvas, there's details for all that kind of stuff. So let's try to figure out why Khan's thing's not working. So he's getting an error on line 2 of q.h. Now you might say, no, the problem's here. No. The problem is here. So if we go to q line 2, the problem is actually not on line 2. The problem is on line 1. The problem is going to be here within linked list.h. So whenever you guys are getting baffling error messages, always look at the line above it. That's, if they forget a semicolon or something, that'll do you. So there is a semicolon here. Let's see if we can determine what is wrong with it. Then temp.cc, just hashtag include ll.h main cout. Hi. Okay, g++ temp.cc. Error. Expected a close bracket at the end of input. You see what the problem is? If you have something bad in the header file, remember it copies and pastes the whole thing in, right? And so the problem is gonna be, let's see, open close parentheses. GG equals capital G. And if we scroll down, if you reformat the entire thing, it can make very obvious where you're missing brackets. Okay, so right there. Okay, so for those of you that didn't hear what I said, GG equals capital G is the command to reformat an entire file in Vim. And if you're ever missing a parentheses or a bracket, as he is right here, we do that. Do a GG equals capital G again, jump to the bottom, everything seems lined up right. Let's try compiling temp.cc, and there you go. So now if we just remove temp.cc because we don't need it anymore, and type make, make clean because we made a different a.out, and then make, and then there we go. Okay, so that is the process that I go through when I have weird error messages like that, where it's like giving me all these baffling errors in the header file, the standard header files, which, don't get me wrong, I've found bugs in them before, but it's not very likely. It's far more likely that you did something wrong in your code, right? And usually the only time I run into those sorts of issues are like when I upgrade. It's like if I upgrade the header files or whatever. Sometimes the header files upgrade, but the libraries don't, and there's like this weird version mismatch problem that I'll get. This variable named dude. So, wow, eyes. Yeah, so that is, yeah, that's the approach. Okay. So the daily quiz from last time, I wrote it and then didn't publish it, and nobody said anything about it. So I just moved the deadline on that to midnight tonight. So make sure you guys get that done by midnight. It's not hard. It's mostly just there to see if you're paying attention to the videos. You know? Okay, so I'm going to go ahead and reboot the server now because the server needs a reboot. All these people that are still working on it, sorry. Okay, so let's go ahead and talk about Rainbow. Wait, no. Richie Blackmore, Ronnie James Dio. I never listened to Rainbow when I was younger because I just thought the name was stupid. You know, like I didn't think that a heavy metal band named Rainbow would be any good, and I was wrong. So if you're into metal, Rainbow, especially Stargazers, like I don't know how many times I've listened to that now. It's an amazing song. It's an amazing song. Okay, we get till midnight to turn in the paper. You do? You get till midnight to turn in the paper. Should be due right now, isn't it? Yeah, it's due right now. Okay. No, the quiz, the daily quiz from last time is due at midnight. I wrote the whole thing and just never hit the publish button on it. Okay. So let's go back to talking about graphs. Your next homework assignment is ready, and yeah, I just server's not down. I just rebooted it. There's a lot of people still working on the Q's assignment. 10 minutes after the deadline. All right. And people don't pay attention when they're frantically trying to get things done. All right. Graph theory. Okay. So a graph is a really important data structure, and these things are used in all sorts of different areas, contexts, things like that. Learning how to traverse a graph is one of the most important programming skills. Out of curiosity, how many people here are not computer science majors? You think your graphs are not right? Either way, Thompson. The homework's being graded, so don't bother working on it anymore. All right. So, yeah, I guess that's fine. Tables, I mean, we kind of want a graph, but that's fine, I guess. So, if you're not a computer science major, then I appreciate you taking this class. And, you know, like I said, programming is everywhere these days. And just getting the extra experience of CSI 41 is going to be really good for you. And also, you kind of can't avoid it. You know, like my wife's a pharmacist, and as a pharmacist, she's had to write programs, and she doesn't even realize they're programs, but she has to write programs, you know. And CSI 41 gives you more experience at just writing programs in general, the logic and critical thinking skills and things like that, but also the data structures. So when you are gonna, you know, do some sort of algorithm, you know, solving some sort of problem in real life, knowing which data structure to pick is really important, right? And so for a graph, which is a very common problem, like it's almost so vague, like it's like, you know, it's just so common. It's like when am I going to use algebra? Like graph theory is comes up all the time. Like something relevant today. Let's say we're doing contact tracing for the pandemic, right? So you've got maybe a graph of people and who they're in contact with, and they have these contact tracing apps that run in the background on your phone, and when you come near somebody, then it remembers their phone and reports it to the government. And then you come near somebody else, and so what happens is that each vertex, each node is a person, and their phone has a unique identifier on it, and that's all held in some government database. And if you're a libertarian, you're probably shrieking in outrage of this notion. I'm just saying how the system works. I'm not endorsing it. So the government has a database of everyone's phone ID, and each phone probably has a unique ID, something like that, maybe generated from their MAC address or something. It doesn't matter. So, kind of scary. Yeah, true. Yeah, like I said, I'm not endorsing. I'm just saying. So, the government has a list of all of your phones, and then when this app runs in the background, it just tracks every other phone you come within 6 feet of. And you can do that by having Bluetooth on all the time, and Bluetooth just is like, hey, who you? And it's like, oh, I'm ID 59. And like, oh, cool. And then it just writes down, I was near person 59. And if they're still near them, then it'll be like, I was near person 59 for 10 minutes or whatever. And all that gets uploaded to the government. Right? Now, let's say that person 59 gets diagnosed with coronavirus. And they get diagnosed with coronavirus 3 days from now. That means that you were probably near them while they were infectious. And so what happens is the state or whoever is running the app will jump to, like, the person gets a diagnosis, and maybe they just go on their app and just be like, yep, I'm positive. You know, then the state jumps to that spot in the graph. There's probably like a hash table or something like that, where you can do a key value pair lookup, and it jumps to that spot in the graph for the person who has been diagnosed with coronavirus. And then you can say, all right, send a message to everybody that you were in contact with, ever, maybe, I don't know, it depends. And just say, you know, maybe these graphs get purged every so often. It doesn't really matter. Let's just say this is, you know, people that you've been in contact with in the past week or something like that. And airplane mode. Yeah, it's an open question. Who is less trustworthy? You know, the Google people, the Facebook people, the Twitter people, the government. I don't know. Trust no one. Not even yourself. It's like some born conspiracy kind of thing. And so the person like hits a button, and then maybe it just goes out one link, right? So in that case, what it would do is go into they're probably not using Adjacency Matrix, but that's the only one I've taught so far, so let's just use Adjacency Matrix as an example. So let's say that you were person number 5, right? So go down to row 5 and just go through row 5 and just send a message in the system to every person who you were in contact with. Do you guys understand? So you grab a row and you just go through the row and say, for each one that's true, send a message. And maybe rather than just being true or false, maybe the entries here are like a timestamp, like the last time you were in contact with them. That'd be probably pretty reasonable. And so you could iterate across everybody that you were in contact with ever, and then just send a message to people that were within the last week or something like that. You know, you could probably configure that, right? And then those people would get a notification on their phone. Excuse me, you were in contact with somebody who was tested COVID positive. Please go into your nearest testing center and get yourself tested. And so that would be it's not like I have to really stretch to find these examples. I sometimes have to stretch to find examples of linked lists. And I think I actually might have found one today. Like when I was actually working on a program today, I actually was like, oh, I should use a linked list. Cool. Because it was a linked list that I kept just iterating from start to end over. And I would just iterate from start to finish, and periodically it would need to delete things just from the middle. And I'm like, yeah, linked list. I'm probably still going to use a hash map. But yeah, I was like, oh, linked list would work here. And I was reading online, and somebody had some example where like you go through, you have a linked list, and then you go through and you insert things in between every element of the linked list. Like there's some algorithm that requires that. You repeat that over and over again, where you're inserting things in between two things over and over again. And that one, like, yeah, linked list would definitely win. Right, definitely win on that one, because inserting in the middle is what they're good at. And so if you have something where you're repeatedly inserting in the middle like that, then yeah, linked list is the way to go. But I had never heard of that algorithm before, which just goes to show you kind of how rare. No, it's not like I have an encyclopedic knowledge of algorithms. There's a lot out there. There's a lot of algorithms out there. So I was like, all right, cool, good to know. I always like learning new stuff. Why do you need airplane mode on a phone? First of all, for airplanes, the FAA has this bizarre rule that you can't have your phones on when you're taking off or landing, and there's no scientific evidence behind that at all. It's mostly just a theater, I think. There have been a few cases where like interference during a landing has caused problems, and they're like, look, we'll just turn off everything to minimize interference. But like the amount of electromagnetic noise coming out of your phone from somebody in row 50 in the back, like it's not like, if that's causing the console in the front to flip out, like you got much bigger problems, you know what I mean? So it's kind of silly, but that's the rule. So you have to, during takeoff and landings, you have to turn off your phones or put them onto airplane mode. So yeah, people literally, you know, there's somebody on the phone at all times with their phone on, like during takeoff and landing, like literally every time. It's just honestly just theater, in my opinion. But it can't hurt, I guess. So whatever. The other reason to use airplane mode is to not drain your battery. If you have a poor cell phone connection, then your antenna drains more power trying to talk to the cell phone station. So like if you've ever gone to like a convention and you're like in an area with poor reception, like your cell phone battery will drain fast as it's trying to talk to home base, and so you need to put into airplane mode sometimes, keep your battery alive. And then also there's privacy implications, like if you don't want your phone broadcasting willy-nilly where you are, which they do all the time, turn on airplane mode. Of course, Apple ignores airplane mode, and it will broadcast your location regardless. And Google too, it'll, even if you have airplane mode on, it'll still pay attention to Wi-Fi hubs available around you. So it knows where you are, even if you turn off GPS, even if you turn off even if you turn on airplane mode. Apple and Google both do some kind of shady business that honestly they shouldn't. And your phone actually still has an antenna that's on. So, you know, you would think the FAA would care about that, but yeah, whatever. So, yeah, as long as your cell phone is on, by the way, like, especially without airplane mode on, if you're just walking around with a quiescent cell phone, the cell phone company knows where you are, right, with a fairly reasonable degree of accuracy, right? So it's not like my cell phone is off right now just because the screen's off. See, it's just quiescent, right? The phone is constantly broadcasting, talking to the cell phone towers, and based on the strength of my cell phone connection to the 3 nearest cell phone towers, you can triangulate your location within probably 50 meters, something like that. And yeah, so if you're worried about that kind of stuff, like actually turn off your phone. And if you're actually worried that much, you might as well take your battery out, except you can't anymore. So hey, so we're living in a world where privacy is actually very hard to come by. A friend of mine tried actually living a life of actual privacy, where like people wouldn't know where he lived, and people wouldn't know what he's up to, and the government doesn't know, and Google doesn't know, and he did that because he was a lawyer in Silicon Valley, and he was like, oh damn, this is scary, and so he moved into the woods and wouldn't give people his phone number, and wouldn't carry a cell phone on him, and things like that. Wouldn't give people's address, because if I knew where his address was, I could punch it into my phone, and if I punch it into my phone, that gets uploaded to Google, and so Google knows where he is now. So he doesn't even have to share his address with Google. If any of his friends knows his address and puts it into the phone book, now Google knows, right? And so his only solution was just to not tell people where he lived, and use burner phones and things like that. It was a really extreme lifestyle, that most people just can't do, So if you want privacy, throw away your phone. Yeah, but it's not even that. Like if you even if you throw away your phone, Hazelton. If I enter Hazelton, he lives at 111 Main Street. Now Google knows where you live, and it's like, if I tag you in a Facebook photo, now Facebook knows what your face looks like, right? And Facebook has a database of people's faces and can do facial recognition, and so even if you never upload anything to Facebook, Facebook knows what you look like. And if I've tagged you, then it knows your name and it knows your face, and if there's security footage from some event, then they could be like, boop, that's Mr. Hazelton, and even though you've never done anything yourself to compromise your privacy, the way that social networking works is everybody compromises each other's privacy all the time. Right? So it doesn't matter if you have a Facebook or not. Like if you've ever had a friend take a group photo with you, and upload it onto Facebook, Facebook knows what you look like, especially if they've tagged it. Like this is Aaron, right? Then it doesn't matter. Facebook creates what's called a shadow account for you, and so they actually have an account on you despite you never having made an account. So it doesn't matter if you know how to register. It doesn't matter. Yeah, they will track everything they know about you, and so on and so forth. So PinePhone, Librem 5. Yeah, I've thought about switching to those, but then I couldn't play Pokemon Go, so. Isn't Pokemon Go a spying application? Sure, yeah. It literally tracks where you walk, and uploads it to Google. Sorry, Niantic, which is a spinoff from Google. And, I mean, Google started Niantic as a way of finding out where people walk, right? So they made a game where people would have it open and they would walk around. And that way Google knows where footpaths are, right? So if you're in a park and you're walking around, you're probably going to follow the sidewalks, and so you can take a heat map of everybody playing Ingress, which was their game at the time, and use it to figure out where sidewalks are in a park. So they don't have that data. They just made a game, and people played the game, and then they figured out where sidewalks were from it. So what if you turn location off? What if you do? It still tracks your location anyway. So you can go into your Google settings and disable location history, so that Google will not retain a record of everywhere you've been, which is, I think, on by default. So location is off for third-party apps. Yeah, but there is what's called background. Like low power. No. Yeah, Bluetooth. grant location services. Yeah, there's like a background location tracking thing that will figure out your location just from what Wi-Fi hubs are near you. Because when Google does its street map thing, so like when Google does the street maps, it's not what I was planning on lecturing on, but you know, if you guys are interested, why not? So this thing here, right? There we go. This is a Fresno Heart, I think, right? Yeah, so have you guys ever seen those Google cars driving around? I had a friend that used to do that. He would just drive around a car all day, and they have like a 360 camera on top, and they take pictures, and they just kind of drive around like this. They're also doing something that Hazleton is probably aware of, which is called war driving. So what Google is doing is that it's also scanning every Wi-Fi access point within range, and it writes down their location. So when they drive by your house, they write down, oh, you've got this Wi-Fi hub up, it's at this place, cool. And then later on, when somebody walks past your house, it's listening to all the different Wi-Fi beacons available, and it's like, oh, we're really close to Kearney's house. So you don't have to use GPS at all. You just base it on because there's Wi-Fi everywhere, you know, these days. You know, there's probably 20 or 30 different Wi-Fi access points within range of my phone right now. You know, and so by looking at that mix, you can know very, very precisely where you are without even having GPS on, right? And the only solution to this is to like change the MAC address of your phone. But here's the other thing: when you walk by somebody's house and there's a new Wi-Fi access point, it knows where you are from all the other Wi-Fi access points. It's like, oh, here's a new one, and then it uploads it to Google. And even if you've turned off all data access to Google, it is constantly uploading data to Google all the time. Even if blank phone, all privacy settings turned on, all data turned off, everything, it is still uploading something like 300 megs of data to Google a day, and a lot of it is Wi-Fi access points and things like that. So Google knows exactly where you are and where every Wi-Fi access point is and things like that. So cool. True story. Due to January 6th, they detained just about everyone who had their phone location at DC who didn't normally go to DC. Yeah, like there's a reporter that was denied boarding on her plane because she was covering the riots, you know. She didn't go into the Capitol, she was just there. And so she got kicked off her flight because they're like, you were at the riots. She's like, I wasn't at the riots, I was covering the riots. You know, it doesn't matter. You know, so... walk around with a BFT jammer. Google's people war driving without them even knowing. Yeah. And they're not doing that because they need free internet, like it's Google, right? It's simply so that they have a physical map of every access point in the world, because GPS is actually not that great. It's like if you just started with a blank thing, you turn it on, and there's no Wi-Fi access points nearby. It actually takes a while for GPS to get a lock on your location. Sometimes like 5 or 10 minutes, and the reason why it goes faster is because it's optimized based on a guess. So if you start off guessing where you are, then you can actually get a GPS fix fairly quickly. If you have no idea where you are and you have a blank GPS just device and you turn it on, it takes like 5 or 10 minutes to get a lock sometimes, which is annoying. Like I'm just sitting there in a rental car, like I don't know where I am. Right? I was planning on using GPS to navigate to the place that I was going to work at, and this thing's just locking on. Cool. And so if you have Wi-Fi though, then it can use the nearby Wi-Fi points to guess your location, and then GPS can refine it very quickly off that. And so you probably never even notice the lag most of the time. Why location accuracy is improved when Wi-Fi is enabled? Yeah. Mm-hmm. Is this the Fresno FBI building? I think this is Fresno Heart, isn't it? Or where is this? I actually don't know where this is. It's across the street from Fresno Heart. Okay. All right. Ooh, Heirloom is good. We have an FBI building. I don't know. Okay, so going back to what I was talking about before I got off on the privacy tangent. Do you guys understand? Like, you know, somebody gets coronavirus. They say, I've got coronavirus. Maybe it goes one person out, and it just grabs everybody they were next to, sends them a message, done. Now, what if you wanted to go 2 people out? What if you wanted to say, send a warning to everybody that either was next to you or was in contact with somebody who was next to you? You know what I mean? Like, so maybe this is me, this is my family, and then this is like I don't know, like my wife's coworker or something, right? And so the wife's coworker would get an email too saying, hey, you're friends with Kearney's wife. Kearney came down with coronavirus. You should get yourself checked out. You guys understand? So that'd be what we might call 2 hops away. You guys understand? Like, not just your immediate people you're in contact with, but people who are in contact with the people you're in contact with. You guys understand? So like this person here, this person here, this person here. Now this person here, you might be like, oh, they're 4-way. No, or 3-way. No, it's 1, 2. It's the shortest path, 2. So what you can do in order to traverse a graph, which is a very common task. Like I said, this is so common. It is so common. You have a graph, and then you need to traverse it. Going 1 hop away is pretty easy, but then if you start saying, okay, go 2 hops away, go 3 hops away, go 4 hops away, you start getting into like, you know, like how many different ways could you get to this blue node here? You know, like you go this way and go this way. You know, there's sort of an infinite number of different ways you can get to the blue node here, right? And so what you do is you use a priority queue. Use a priority queue, and you push all of the original person's friends onto the priority queue, sorted by distance. They're all 1 away in this case. Easy. And then you pop them off the priority queue 1 at a time, and when you pop them off, you so the way I always describe it is this. You actually have 2 data structures. You've got a process queue. Processed queues. Let's number these 1, 2, 3, 4, 5, 6, 7, 8, 9. So you start off by adding all of 1's children, and you say, okay, we're done with 1. And then we have what's called a 2 process list, and that is a priority queue. So this is a prio queue or a heap. I just called it a prio heap, prio/heap. Okay, and then this is usually a hash table. The key is the index number. And okay, so we start off by adding all of 1's children and put 1 on the process list. So all of 1's children are added to the 2 process list like that. Then you repeat. What? Yeah, that's all you do over and over again. So you take the closest person off the 2 process list. In this case, either 2, 3, or 4. They're all 1 away. Doesn't really matter. I'll just go, I guess, go in numerical order because I think I've inserted them in the order they're going to get processed. So that'll make it easy, I guess. So we take 2 off the list here. We add it to the processed list. Now we add all of 2's kids that are not on either of these lists. So how many of 2's connected friends, children, whatever you want to call them, how many people connected to 2 are not on either of these data structures? What do you guys think? None. Okay, easy. Then repeat. All right, let's take the next person off the 2 process list, 3. Now we're going to add all of 3's children that are not already on one of the 2 lists. Okay. So 3's children are 1, 2, and 5, right? And you do that, you can just go through this, right? So if we're on 3, you know, we're on 3 here, then we just go through and add all of its children to the toProcess list if they're not on one of these lists already. Okay. So how many kids does 3 have that have not already been touched somehow? One is already done, right? We got 1 here. 2's already done. 2's here. We don't put ourselves on the list. That'd be an infinite loop. But we got 1 child. Very good, Emma. Yeah. We got 1 child, and it's 5. Good. So 5 goes onto the toProcess list, and we're now done with 3. So 3 comes off, and we repeat. So 4. How many kids does 4 have that are not on the not on a list already? I guess I can just circle it. So if I circle it, it means it's toProcess. And if it's crossed off, it means it's been processed. So how many kids does 4 have that are not, and which ones are they that are not touched already? 2? Yep. And which ones are they? 6 and 7. Good. Very good. So we add 6 and 7 to the toProcess list. And then 5 is now, or sorry, undo. Can't undo it. Okay, sorry. 4 is now done. That was 4. Okay. We'll now process 5. 5, you go through all the kids of 5. 3's been done. 4's been done. 6 is on the toProcess list. Oh, 8. Okay, so we'll add 8 here, and now 5 is done. And then we go to 6, and 6 is going to say 5 is already processed, 4 is already processed, 7's already on the toProcess list, 8 is already on the toProcess list, but 9. Okay. And then 6 is done, and then 7's got no kids that we haven't seen already, so 7's done. And then we go to 8, and 8's got nobody we haven't seen before, so 8 is done. And then we go to 9, and 9 hasn't, yep. And then 9 is done. And that's it. So that is how you would traverse a linked list. You need 2 data structures. And this is why I changed CSI 26 from requiring 40 to 41. Because in order to do these algorithms, you have to know what a hash table is, you have to know what a heap is. Say I love you. I had students in the class that only had 40 and they only knew vectors, and doing this with vectors is painful because it goes from being a order 1, right, hash table. For hash table, have you seen 5 before? Yes. Okay, cool. Order 1. It goes from order 1 to order n. With a vector, they would scan through the whole vector every time to see if 5 has been found. Okay, yes, we have. Return true. And so it's way, way slower, right? And for the heap, you want to always know who is the smallest person in the heap. What they were doing is putting all of the people in the heap and sorting it based on their distance from start. And so it turned an order 1 operation into an order n log n operation, because literally every time they would call sort again on the vector and then take the person with the smallest distance. Every step, somebody who's taken this class would be doing order 1 for processed and order 1 for heap. And because they're using vectors, this was a heap. If you're a smart, super cool CSI 41 person, you would use the heap and a hash table. And these are both order 1, heap for the smallest. And I guess when you pop it off, it becomes a log n operation. And then for the CSI 40 people, the CSI 40 people would do an order n delete to get the smallest person, and they would do an order n log n sort to find who you could probably do an order n search also, but then you gotta erase it. I don't know. Either way, it depends how bad you are, but a lot of them were doing it this way, where they're just sorting it and then deleting the first element. And to delete the first element of a vector, is order n instead of order 1. And so it was just really bad performance. And the really scary thing is it works, right? Like, it works fine. If you've got 20 graph, if you've got 20 nodes in the graph, you got 50 nodes in the graph, it works fine. The trouble is when the thing starts scaling up and they're like, why is my thing timing out? And so in order to see if a vertex has been processed, with a hash table, it's order 1. With a vector, it's order in, right? So do you guys see the difference in running time here? Do you guys see the difference in running time? Like for a heap, you can get the nearest person and order one time, but if you pop it, it's order log n. So we'll call it log n. It's almost free. Log n's very close to being free. And if you're doing it with vector, they would either search through the entire vector and then delete it, just order in, or they would sort it and then delete it, which is log in log n, and an order in. So if you had 1,000,000 elements, this code would be 1,000,000 times faster. I don't know, something like that. So it's yeah. So you'd go from being able to process 1,000,000 nodes in a second to 1,000,000 nodes in 1,000,000 seconds, something like that. Yeah. How long is that? Why is my code taking forever? 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. So it goes from a second to 11 days, right? That's why 41 is important. So seriously, like if you guys are actually in a program, you need to know how to program. You need to know how to put the pieces together with if statements and for loops and things like that. But man, data structures. Any interesting problem you're going to solve is going to have a lot of data, and so you have to think, McFly, think, right? What data structure is right for the job? In this case, it would be 2. So, all right. So this is we talked about the adjacency matrix last time. In reality, adjacency matrices are not very commonly used. The reason for that is because there is not just time complexity, but there's also something called space complexity. How much RAM, right? This is running time. This is CPU, your CPU resources, and this is your RAM resources, right? And we're used to just sort of discarding RAM as a factor these days. RAM used to be very expensive, right? Like I was talking about in my game development class yesterday. The reason why the person who invented Z-buffering dismissed Z-buffering as being impractical was because it would require like a meg of RAM to implement, right? And but to be fair, this was in the 70s, and in the 70s, a kilobyte of RAM was $1,000. So you're talking $1 per byte of RAM. So a megabyte of RAM was $1 million. And so they're like, nobody's got enough money to implement that algorithm. So nowadays it's like, I don't know, should I buy 16 gigs of RAM or 32 gigs of RAM? I guess I'll just buy 32. I don't know. It's like $20 difference. Whatever. I'll buy a little extra, just to future-proof myself a little bit. That was literally my thought process when I put this system together, because I'm like, I can't think of any needs for having that much RAM, but at the same time, like, I don't know, the difference in price is so trivial that I just, yeah. So I've got 20 gigs on standby right now that just aren't being used for anything, right? So, yeah, if I had bought 16 gigs left, I would still have 4 gigs of RAM free. And right now I'm streaming on Discord. I'm streaming, so yeah, Firefox open. So yeah, it's like, I don't know, but I would feel a little nervous getting that close to my RAM limit. So yeah, just throw some extra RAM at it. 3080? What do you mean 3080? Where did you see that? Oh, can't see that on here anymore. No, I do not have a 3080. I have a 3090. So, RAM, space complexity, is how much RAM we use. Space complexity is how much RAM we use proportional to the size of the problem. Okay? So if we have 3080, you insult me, sir. You guys kill me. It's funny. All right. So if this is the problem size, and problem size is always n, right? Normally we talk about CPU time, right? Like this would be time. And so for an order n algorithm, it would look like this, right? Here, let's actually go into OneNote. Yeah, I signed up to buy a 3090 6 months ago, and EVGA has at MSRP. I bought it below MSRP, my friend, below MSRP. So EVGA has a queue, and how long is the wait in the queue? Mine was about 6 months. So this guy took like 3 months or something like that. North American queue summary. So anyway, so EVGA has a queue, and they are currently processing orders from, it looks like on the 3090s, from November now. Right. So 6 months. Yeah. So as supply catches up to demand, like I'm sure the queue times will get shorter, but there you go. So I signed up for 3090 and in September, and then last month it popped, and I bought my 3090, and they honored the original price on it, and actually knocked $70 off for whatever reason. I don't know why. And so if you want one, you can sign up on that. I was getting tired of trying to hit up Newegg and things like that. So. What is VRAM in a video card compared to regular RAM? Do you get it using the Elite membership thing? You just have to sign up on their website, then you can queue. Okay. What is VRAM in a video card compared to regular RAM? It's called GDDR6 or something like that, and it's a dual ported. It's a topic for another time. So it's optimized for the graphics workflow. That's what it is. Okay, so let's do this. So if n is the problem size, like let's say you've got a vector with 1,000,000 elements in it, then n would be 1,000,000, right? This was the whole point of your queues assignment, right? This is the size of your vector, and there's still 4 people on the server trying to get the queues assignment done. And so let's say this is the running time. So if you had something that looked kind of like this, what big O do you think that is? So as, you know, this is 1, and that's, you know, 500, and that's like 1,000. What big O, and the running time goes from like, I don't know, like 1 second to like, I don't know, 200 seconds to like, I don't know, 400 seconds. What, you know, these things are rarely perfectly shaped, right? Yeah, this would be an can you see it? The graphics card. It's I guess it seems a bit weird. You want to see my graphics card? Don't rob my house, please. I don't know if that'll turn out. It's a little bit blurry. That's the that's the inside of my case there. All right, yeah, so this would be order n, right? So, what if it looked like this? What order is that? That is also order log n. Yes. Not also order log n. You are correct. That is order log n. Now, this doesn't just apply to running time. This can also apply to RAM as well. So we can not just use time, we can use RAM. And so how much RAM does an adjacency matrix take up? Okay. So if you have, in this case, 5 nodes on the graph, right? You got 5 nodes on the graph. How much RAM does this require? How many bits are in here? A bit is a 0 or 1. So if you got 5 graphs, how many bits do you need to hold the adjacency matrix? Oh, we can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm counting 25. Okay, it's a 5 by 5 matrix, right? And each entry is 1 bit. In this case, it's just true or false. And so we have 25 bits of storage. And so what if we had a 100 by 100 matrix? How many bits of storage would we need for that? Yeah, and so there's the eraser tool. So for the adjacency matrix, we have an order n squared space complexity. You guys see that? So these things work fine for like small graphs, but if you have a graph of like Facebook, you know, like every person on Earth, you know, 1 billion by 1 billion, like even Facebook doesn't have enough RAM to store that probably, you know what I mean? So, do you guys understand what I'm getting at here? So this, it's not very commonly used because of the order n squared space complexity. You guys understand? Yes? No? Do you see the weakness of this? Cool. So one observation that applies in real life, maybe not in all situations, but in real life, so commonly enough. Out of the billion people on Facebook, how many of them do you know in real life? You've met 1%, 2%, 3%, all of them. What percentage of the billion users of Facebook would you say that you know in real life? 0.5%, 3%. Shahab knows what 30 what is it, 3 million people? 30 million people? 30 million people. Yeah. 3% of a billion is 30 million? 10% would be 100 million. 1% would be 10 million. Yeah, so 30 million. Yeah, so you are in the 0.01%, Shahab. Right, it's a very small fraction. And so that notion is that the matrix would be what's called sparse. So sparse means there's not a lot of connections. Like if you have a sparse graph, you've got a billion nodes, but very few of them actually connect out of any one, right? You got a billion people on Facebook. Maybe you've got 500 friends. Cool, good for you. You're popular. You got 500 friends. That's nowhere near the billion people on Facebook. You know what I mean? So when you have a sparse graph, we tend not to use an adjacency matrix. Adjacency matrices are used when we have what's called a dense graph. So a dense graph, everybody's connected to everybody else, and so you need n squared connections anyway. Might as well make it a matrix, right? But in real life, most graphs are sparse, and so for that we use an adjacency list instead. So we use an adjacency matrix when it is dense. Sometimes we use an list anyway. But an adjacency list is used when it's sparse. So what data structure do you think we use with an adjacency list? What data structure do you think we use when we are talking about a list? Hash table? Linked list? Well, let me show you what it looks like. So, a adjacency list. Discard. Let's just go back into OneNote. It looks like this. So let's say that you've got 1 billion people, right? So what you're going to have is some sort of array, so it's maybe a vector. And each entry in the vector is a linked list. So this is person 1, and person 1 is friends with person 10, and person 20, and person 1000, and person 2. Whatever. It doesn't have to be sorted. And then person 2 would be friends with person 1, and maybe person 20 also, and person 7, and person 100 million and 1. Right, because it's Facebook, right? And so what you'll have is a linked list for every person. So there's a vector, and it might not be a vector. If you're talking about like actually like Facebook, there's not going to be like a vector. You know what I mean? Like they're going to have some sort of distributed, concurrent system that multiple nodes can access in parallel and things like that. But you can think of it as a vector. It's fine. It'd be some sort of like distributed vector, some parallelized vector, something like that. And so you can just be like, hey, give me all the friends for person 2, and then it'll be like person 2 is friends with person 1, person 20, person 7, and person 100 million and 1. And then and so like when you do a find, on Facebook, search from posts from people you know. So for example, somebody made a funny cat meme or something the other day, and I could be like, okay, find from people I know, cat. And then it would go through, it would pull this list and go through each of their post histories and search for the word cat. Okay. So this uses a combination of data structures. Yeah, and that's kind of what I'm trying to get at now that we're at the end of the semester, which is that lists and vectors and hash tables are building blocks for like real solutions, right? And so did they write their own linked list class? Actually, probably. Probably it's Facebook. Like they probably there's probably enough enough of a payoff for them to very heavily customize data structures exactly to their needs. Because imagine if you could save Facebook 1% of their power. Like how much is Facebook? What's their power bill? You know what I mean? Like if once you get to that level, like yeah, you're not probably gonna use the standard library, but at the level you're at, if you wanted to make an adjacency list, I would take a vector and make it a vector of lists, and that's it. And it would be like a vector of angle bracket of lists of ints or something. I don't know. Depends. I mean, I guess you can't have more than 2 billion users, or unsigned ints, or unsigned long. It doesn't really matter. Yeah. And I do that, and that would be called my my graph or something. Yeah. And then basically, if you want to make person 1 friends with person 42, you would say vector dot at person 1 dot what is the linked list insert thing? Is it just called insert? C++ list. Why does CPP reference not come up by default? Sewing C++.com. All right. Insert. Yeah. Okay. So vector.at_i.insert 42. Okay. And then that would just slap a 42 at the end of the list here. That's it. Or maybe it comes at the head. Doesn't really matter. If you wanted to maybe speed that up, searching for if somebody's your friend or something like that, maybe you can make that a vector of BSTs or something like that, right? So you can make it a vector, like if you wanted to speed that thing up, you can make it a vector of sets, you know? That might be a good idea. Yeah. Then to search for if somebody's your friend, it would search in login time versus end time, something like that. That's the idea, right? So you use all of these components as building blocks for actually building real solutions. If you're going to go into data science, then you have to know them as well, because how are you, if you're going to be processing every cancer case in America, you'd better make sure that you're doing that in as efficient a method as possible. Otherwise, it runs forever. One of the big issues that we had back in the internet boom, which was the internet really became big in 95 to 96. People started realizing there was this thing called the internet. The internet had been around for a while, but nobody had heard of it. I hadn't heard of the internet until 92 when I went to a Linux, not a Linux user group, but what you'd probably call like a Linux user group meeting today, hosted at UC San Diego. I was a freshman at the time. I had access to the internet. I just didn't know what to do with it. And my mom had been working with the San Diego Supercomputer Center, and she got me an account on one of their VAX machines there. And I was just talking to a guy. I'm like, I don't know what to do on the internet, dude. I'm on this thing. Like, I didn't even know it was called the internet. I'm on this thing called ARPANET or something, and like, I don't know what to do with it. He's like, oh, let me tell you about the internet. You've never heard of the internet? Oh, it's amazing. You can pirate software. You can download porn. It's amazing. I'm like, this is not my experience. I've just been on this VAX machine trying to figure out this Unix thing. Or no, it wasn't even Unix. It was VMS. It's like their own operating system. I'm like, I'm not seeing any of that. He's like, oh, let me, and he got some printouts. He's like, oh, let me tell you about the internet, and I was like, oh, that's cool. And then in 95, the rest of the country sort of discovered the internet. Good luck having the lecture on YouTube. And then around 99, there was the internet boom. And that's when all these startups happened. PayPal was around then. Elon Musk founded one of the first internet banking sites. And he merged with Peter Thiel's competitor. They were competitors, and they formed PayPal, I think, as a result of that. It's been a while since I read about that. And PayPal was a way you could digitally send money to each other. That exploded in popularity. It was used in like eBay. eBay came online at this time. Amazon really took off at this time as an online bookseller. Originally, Amazon was just a online book company, and you could like go onto their website and buy a book, and they would mail it to you, and you're like, oh, that's cool. You can actually buy things on the internet. That's neat. I don't know if I trust giving my credit card over the internet, but these guys sound reputable, and other people have used it. And then in 99, 2000, all of a sudden, everything was internet, everything. And like there was a startup being founded every day. All of my classmates in the computer science department were in high demand for, like, you have a pulse and you can program, come work for us. We'll offer you $1 million in stock options, that kind of stuff. Sky was the limit. There were some crazy times in Vegas at the time where, my friends are doing craps at $100 a throw of the dice, things like that, because they were paper millionaires. They had so many stock options in like mp3.com that they had a beach house in Pacific Beach, and they were driving Ferraris, and they didn't actually have $1 million. They had $1 million in paper, in stock options. They couldn't sell it for a year. And then, of course, a year later, the stocks tanked. There was a stock market crash and all that kind of stuff. And, they were indigent at that point. But they all thought I was stupid for staying in college. And so I stayed in college because I wanted to get my graduate degree. And we had trouble. We had trouble finding people to work on this kind of stuff with us because so many people were getting hired away by industry at very large amounts of money. You're a junior in high school, come work for us for $200,000 a year, And the dot-com bubble, yeah. And it was a crazy time. Like the recruiting events at UC San Diego, there's just people everywhere, and there's companies, and everyone's just like, come on, come work for us, And it was all stock options. Like none of the money was real. You know what I mean? Like you'd get paid $50,000 a year plus you know, $300,000 a year in stock options or whatever, you know, and then the stock options never materialized because the bubble popped. So some did. A friend of mine, she started a security company. She's one of the first 10 founders of it, and ended up becoming quite an important large security company, and they ended up getting bought out by HP. So it's called HP Fortify now, and it worked out pretty well for her. You know, she made pretty decent money over the years. But my friend who got a job at Microsoft and just worked as a wage slave for, you know, a long time, he made probably about the same amount of money, and she was a success case from a startup. You know, like they actually did well, and they didn't go under like 90% of startups do, and they got bought out, which is the dream scenario, and you know, like they did fine. They have a condo in Palo Alto. You know, they did fine. But this is what irked me. So when I had to work with people at the San Diego Supercomputer Center, they couldn't find computer science people. So they were finding like physics majors and things like that, like people that wanted to get some experience like doing programming because they saw how hot the field was. And so we have people who have no background in data structures trying to do, you might even call it data science these days, right? Like I was processing terabyte sized data sets, you know, and like mining them for data and things like that. You might call it data science these days. I don't know. But the people that I was working with had no concept of like, I don't know, what's a hash table? What's a heap? What's a, you know, and so they just wrote code that was really, really bad. you know, if I can summarize it, it's not like their code didn't work. It just didn't work well. Right? Because if you used the wrong data structure for the job, it just wouldn't work well. And I would always have to constantly be rewriting their stuff and things like that because it was just not good. Silicon Valley, yeah. Yeah, and, you know, there's a certain, you know, bit of that, you know, it's 20 years later at this point. You know, Silicon Valley still has a lot of that startup culture going on even to this day. You know, like if you work at a company, some of your coworkers are like, hey man, we're going to do a startup. You know, are you going to quit? No, we're just going to do a startup, you know, and so like on weekends, we're going to meet together and start up a company. And like that culture is still alive and well, you know. The trouble is like you just can't do it in your garage anymore because nobody can afford a garage. You know, if you have a garage in Palo Alto, you don't need to make a startup because you're already worth $9 million or something, you know. Because housing prices in the Bay Area are so incredibly stupid. It's one of the nice things about the pandemic is that people left the Bay Area. Okay, so that's basically how you do graphs, right? So basically, if you wanted to say, is 20 and 1 a friend? Remember how we talked about the commands to, you know, the main commands, insert, and then search. So is 42 a friend of 1? You would say vector dot at 1 dot search or find or whatever 42. True or false. You know, delete, you just pass it off onto the erase function. You know, easy. And if you want to just print out all the friends of person 1, you just say for every int I in vector dot at 1 ci. That's it. So for every integer in list 1, print them out. There you go. That's all the friends. That's it. That's how hard it is to make a graph. You know. Are you guys with me on that? But it's 2 data structures in 1. And this is why CSI 41 is so important. Like I said, when people try doing computer science and they haven't taken this class, they end up, I don't know, it ends up not really going very well. And so you can use a list here. I would probably use a set if it was up to me. You could probably make a vector as well. A vector of vectors. That's fine. Just push back every time, you know. Erasing would be a little slower, maybe. I would probably use a set. Yeah, why not? Go. Rent out your garage to somebody. Yeah, very common. Yeah, it's very common. So you guys understand? So you just it's kind of like how I made that hash table. You know, you just made a vector of sets and just use the set, insert, search, and delete functionality to handle it for you. You guys with me on this? And so what's nice about this is the space complexity doesn't explode, right? The space complexity is proportional to how many friends there are, you know? So rather than being proportional to the number of people, it is proportional to the number of people times the number of friends each person has, right? And this is usually, it could be as bad as n, in which case these would be the same thing. Like if everybody is friends with everybody, like, then it becomes n squared. Usually, though, the number of friends you have is way, way below that. So it's pretty much like order n rather than n squared if you have a sparse graph. Does that make sense? And again, do you see why, like, being able to talk in terms of big O is like it's just part of the lingo of computer science. That's just how we talk about things. So be n times m, and m is friends. Okay, average friends. Make sense? We'll walk down memory lane. It's the end of the semester. You guys can handle a story. Okay. Questions? All right. So for your homework assignment, your next homework assignment, let's take a look at that. You guys are going to implement a Java Jeopardy. You guys are going to implement a multiplayer version of Jeopardy. Okay. In Java. One of my wait, was it you? Did you recommend they could do it in C++ as well?
Wait, Java Jeopardy?
Mm-hmm.
I don't think so.
Somebody recommended. I don't know. I was talking to somebody about this, and
I'd still recommend it.
You recommend Java or you recommend C++?
Either one. Having a choice, I suppose. I don't know.
Okay. So this is going to be your final thing. It'll be due at the end of the semester. There's no final, so I've given you guys a working chat client and server. So what we have in here is we got server server dot. I've made a shell script so you don't have to type Java server every time. So server.sh, and you give it a port number, 9000, and then the server's running. And let's snap that over here and duplicate this. Java Jeopardy, and then you run the client, and the client yeah, just the port number. So for the shell script, it just hard codes in localhost for you. You don't have to use the shell scripts if you don't want to. I just get annoyed at having to type things, so I always start making shell scripts and aliases and things like that. So if you want to see all the different aliases I have, just type alias, and you can see all the different aliases that are there. Okay, so client.sh, port 9000, please enter your name, Bill, and then Bill's connected, and then hi, and then, so I type hi here, it gets transmitted over the internet, the server reads hi, it echoes back ACK, I think, which means acknowledge or something like that. And so you type in SD, it sends it over here, it sends back ACK, it prints ACK. You don't have to, don't do that, like don't print ACK while you're making your Jeopardy thing. What it should do is, you know, wait for 2 people to connect, 3 people to connect, whatever, and then give them a quiz, right? Like maybe ask them 10 questions. If we run Java underscore will be connected on it, I don't know what that means. So what you need to do is make a multiplayer quiz show that's multi-threaded. I guess maybe technically it doesn't have to be multi-threaded, but I'd probably recommend doing it that way. Simply because you'll learn about threading that way, and if you want, you can probably do it in some sort of single threaded non-blocking IO way. I don't You could probably re-implement this using C++ if you want, but Java is a lot nicer. I don't know. So let's go over what I've given you. Then server.java. So let me go over what I've given you. Okay. And then we'll finish our lecture on graphs next time. And maybe I'll do a little code demo for graphs next time as well. It'll get you guys ready for CSI 26 if you're obviously not in it already, like some of you are. So here's what I'm giving you. Okay, and there's basically just kind of a couple things you need to add to it, but with what I've given you here, you should be able to make it work. Okay, so scroll down a little bit, and we've got main. So remember, in Java, everything's inside of a class. This is called class server. Server's got a static void, public static void main inside of it, so it is launched by typing cat server. It's launched by typing Java server, right? And then that's the command line parameter you pass to it. And so when you do that, it runs main. It runs main down here. And if you don't provide a command line parameter, it'll tell you to type in a port number. It converts the command line parameter into an integer. That's the port number. I've been using port 9000. You guys should use your own port because each port can only be in use by one application. If I hard-coded this at 9000, one student at a time on the server would be able to run the server, right? So when's it due? It's due on the last day of the semester. Okay. So grades go in on Monday after finals week. And so the last day of the semester is technically next Friday. So, yeah, just if you choose port 9000 and it's in use, pick a different port. Okay. I don't think this does anything. You're doing this one partnered. Yeah, I don't think that actually does anything. But whatever. All right, so this is obviously adapted from the code they have. I have kind of redone it a little bit to make it easier for you guys. I can push out all the knock-knock code as well if you want. Do that right now. Sudo deploy homework CSI 41 sockets. I've already deployed it, I guess. Okay. CD sockets boost if you want to see that one. Sockets boost. That's the C++ version. So if you want to do it in C++, there's demo code in there for doing it in C++ as well. Ooh, okay, that took a while to deploy. Somebody's still using the system. Interesting. Okay. So this is called Java Jeopardy. And so you guys are all familiar with Jeopardy, like the TV show with Alex Trebek, rest in peace, you know, hosting it since like the 80s or something like that. I had a friend who went on Jeopardy, and said Alex was a really nice guy. I watched that episode. I was kind of irked though, because my friend gave Martin Luther King as the answer, and Alex Trebek is like no, and all the other people are like, you know, because it was like who was responsible for. You know, who wrote the letter from the Birmingham jail, and he's like Martin Luther King, and Alex Trebek was like, no. It's because the answer was Martin Luther King Jr. Okay. So what happens is the server creates a new socket like this, and so it starts listening on port 9000. And then, while true, because that can never not be true, the server accepts a new connection. So when somebody connects to the server accepts the new connection. This blocks. So the highlighted part here blocks. It waits. It sits there and waits until a client connects to it. When a client connects to it, it creates a new socket, and it spawns off a new thread. So it creates a new thread, passing in the socket that was just created, and passing in the thread count so that each thread has its own unique thread ID. Because when you are going to be doing some sort of data structure to hold, Bill has a score of 5, Muya has a score of -500, whatever. Um, you need to have some sort of synchronized data structure between the different threads, right? And so you need to know I'm thread 1, you're thread 2, you're thread 3, right? And so it passes in the socket, and the socket is just used to communicate to and from the client, and it needs a thread ID. The thread ID is I'm client 1, I'm client 2, I'm client 3, and you just use that as an index into some sort of data structure. Like I recommend using a concurrent hash map. A concurrent hash map is a synchronized data structure, so it's thread safe. You can have multiple threads reading and writing to it at the same time. It handles it fine, like champ. So, yeah. So down here, it creates a new socket, and it passes to it the thread count. It starts the thread running. I could have put this onto one line, but it looks a little weird doing it on one line, so I split it into 2 lines. I then, the server itself will print client 0 connected, client 1 connected, whatever. And the thread count will increment each time. So each thread will get its own unique thread ID, and this monotonically increases. So you don't have to worry about like multiple games running at the same time. Like we're doing this as basic as possible. So the server will just wait until 3 people are connected, and then it will go and just ask 10 questions, and each person will enter something. It can block until all the people have entered something, and at the end, you just basically, if you get a question right, you win that many points. If you get a question wrong, you lose that many points. I want potpourri for 100, whatever. So if you get the question right, you get 100 points. If you get it wrong, you lose 100 points. You can do double Jeopardy if you want, or final Jeopardy. I don't know. Like you can do whatever you want. But the basic thing you have to implement is this: 3 people connect to the server. Once 3 people are connected, then you begin the quiz show, and you print a question to the client, get a question back. If they get it right, give them points. If they get it wrong, they lose points. Once all 3 people have answered, then you move on to the next question. After 10 questions are done, you print out the final score, and you're done. And then the server can quit, I guess, at that point. If you want, like I said, you don't have to handle multiple groups of people playing at the same time. We're not doing anything professional here. This is simply to teach you guys about sockets and to teach you guys about threads. Forgot to check how to partners. I had one on RPG. Yeah, anybody who wants to sign up, again, this will be self-sign up for partners, so I'm not assigning partners anymore simply because so many people just vanish and just don't. It's really one of the downsides of being in a coronavirus environment, especially towards the end of the semester when people are kind of burned out. It's like, hey, let's work on the project. A group of 23. Are you going to have a group bigger than 2? My partner didn't do anything. Hasn't even joined the class since then. I don't know. Last time I did a group of 6. How did that work out? I did 3 groups of 6 just to see if that would work. Did that work out for you guys? The trouble is when you get into a large group, everybody waits for everybody else to do something. Like I was on a grant with 10 people, all authors on it, and so nobody wrote anything because nobody wanted to like step on each other's feet. Yeah, so message Aaron, and then you guys can sign up. How many people dropped? Not too many, but a lot of people just became zombie students where like they don't do anything. They're still in the class. I don't know why they wouldn't. Because you guys know you can get an emergency W, right? And those of you that are here aren't the people that need to hear that, right? You can still apply for an emergency W and get a W instead of an F. So how is this going to be graded through an input tester? Nope, this is going to be hand graded. So if it's at the same speed as me grading the RPG assignment, it'll be graded by next fall. No, I'm kidding. I just forgot about the RPG assignment, honestly. So no, it'll be graded over the weekend before grades go in because it has to be. So that'll be a fun weekend for me. And I should have all the RPGs graded soon. That's next up on my priority queue. Okay. No, it is fully freeform, and it's one of those things where if you do things that are cool, that are amazing, if you want to build a GUI client for it, doing GUIs in Java is not hard. You can actually run it on your local PC. connect over the internet to the server. The server could be console based. The clients could be AWT or Swing, which allows you to have a window and buttons and things like that. Yeah, go for it. X credit galore. Okay. How many points for this assignment? Why is that going to affect if you do it or not? 9 million points. You're thinking of skipping it? All right, it'll have to be 20 points then. Okay. All right. Did Muya get like 10 bonus points for this one? Muya, did you do this one? I think I might have not done this last year.
We didn't. We never did Java networking. We were too busy doing way harder C++ networking.
Yeah, Battle Soup. That's right.
And I completely skipped that assignment. I'll be honest.
Yeah, I'll allow you guys to do this in C++ if you want. I pushed out the sockets boost examples for you guys.
Just don't do it in C++. It's way easier in Java.
Yeah, it's up to you though. It's up to you. So let's look at the client code real fast. So when you compile this, I've got a makefile. So you type makefile. Remove char.class clean. So when you type make, it'll build all the different things. And so I just made the makefile right before class. So the client is pretty simple. Basically, the client is just a page of text, and it's as simple as C in and C out, right? So all the networking stuff is already set up for you. So for example, prints to the screen. This is like C out. Please enter your name, and then it reads. It's like get line, but it's called read line. Yay! And so it reads a line from the keyboard. Bill Kearney, cool. And then it writes to the socket. So it writes to the socket, Bill Kearney connected. Boom, there you go. And then the server thread needs to parse that or something, or be like, all right, cool, that's the person's name. You can change any of this that you want. So maybe the first thing you send is just the name, and then it takes the name and puts that into some data structure. All right, Bill Kearney, set their score to 0, whatever. Okay. And then all the client does is it waits for the server to send them a line of text. If the internet goes down, it bails out. But if the server sends them a line of text, this returns. It prints what the server sent them. If the server sent them quit, then it dies, I guess. Otherwise, what it does is it reads a line from the server, prints it to the screen, and then it reads a line from the keyboard. So the user's like so maybe the server sends to you. What was Taylor Swift's first boyfriend's name or something like that? Because 2 years ago I did this assignment and it worked really well. Students had a good time with it. And the most memorable one was Josh Gomez's Taylor Swift quiz show. And so what was Taylor Swift's numeric album called? You'd type in 1989, and hit return, and then it sends over the network. So this reads from the network here. That just reads a sentence from the network. And then this writes a sentence to the network. That's it. That's how easy it is to do networking. Like, a lot of people think networking is really hard, and it's really not. You just, you can read a sentence from the network, or you can read a sentence from standard input. Same thing. You see that? Same code. This is reading from the keyboard. This is reading from the network. That's it. So the only thing you have to be careful of is if you're reading from the network and the server never sends you anything, then nothing happens because it blocks, right? So you have to just make sure that the way that I recommend you do it is the server sends exactly one thing to the client sends one thing back to the server sends one thing to the client, and you just alternate doing a read and doing a write. Okay, as long as you follow that pattern. So don't send 2 strings, don't read 2 strings, just send 1 string, then receive 1 string, then send 1 string, then receive 1 string. If you do that, you'll be fine. And maybe you have to parse the the packet or something. You know, client, you know, I don't know, disconnected, and you have to like check to see did they type in disconnected or something. You know, you do things like that where you like look at the thing and parse it. Jeopardy and sockets are used together. You're still confused where we should code. Both of them. You have to probably, the client's probably pretty close to like not needing much of anything. You probably need to clean it up a little bit because right now it's doing things like this, you know. But you are going to be programming inside of server.java, and inside of server.java there is a nested class called server thread. And so there is one server thread for each client connected. And so the server itself, when somebody connects, it spawns off a new thread. Somebody connects, it spawns off a new thread. Somebody connects, it spawns off a new thread. And since this is within the server class, any variables you put here are shared among all of the threads. And so what you want to do is put here some sort of data structure, a shared data structure that they can all read and write to. And then this is where you are going to write Jeopardy. Okay. So right now all it's doing is reading, all the server does is it reads a sentence from the client, and then it writes ACK back to the client. So the client types hello, and the server reads it and prints it to the screen, prints to the standard output, whatever the client typed, and then it just writes back to the client ACK. That's it. This is the entire server right here, right now. So all that's happening is the client sends a string to it, the server prints it, then it just sends back acknowledged. And if anybody ever types quit, then it dies and goes away. If the client disconnects, it closes the socket and things like that, and then the thread goes away. And so it's a very elegant, scalable model. It's not high performance computing at its finest. This doesn't scale past 100, 200 threads, something like that. There's better architectures for like really big scaled systems. Can you do a timed question? You could, or you can make it so that the first person to answer a question gets it right. Everybody else gets a sorry, somebody else answered it before you. I personally almost wouldn't worry about it. Or you can just say if they take more than 5 seconds, they get no points either way. Beep beep. You know. But I don't want you guys necessarily needing to get into non-blocking I/O, because non-blocking I/O gets tricky. Because like if you're waiting to read a line, and then they take too long, and you don't read a line, and the client sends something to you, it's going to wait for that to be acknowledged, and you're not. I wouldn't. You maybe just scale their points based on how quickly they answer it. That could be doable. So give them 4 options, A, B, C, or D. Which one's correct? If they type C quickly, they get more points. Something like that. That's doable. This is the whole thing. And so what I recommend is you guys examine the code that I've given you. Learning from experienced programmers are the best way of doing things. Maybe just make a variable or something up in here and have the different threads read and write to it. Remember, there is like the synchronize keyword. There's also atomics in Java too. So, each thread can read and write to it. Needs to be static. So you do something like this, where this is going to be shared among all the different threads. So all the different threads can read and write to chat count, right? And if you're going to be doing that, you need to add the synchronize keyword on it. Synchronize means that only one thread can be inside of it at a time. It's like it's putting a security gate around the variable. So if one person goes inside the security gate, it slams shut. Nobody else can go in until they've finished reading and writing to it. When they leave, it opens back up. So that's how you make thread safe things in Java. Modifier synchronize not allowed here. Okay, never mind. Then we can't do that. So let's see here. I'd have to look that up. But that's the general idea. Okay. Probably use an atomic there or something instead. All right. Well, the Jeopardy starts as soon as the client is connected. You need to wait until 3 clients are connected. So sit there and block until the thread count equals 3 or something like that. Right. And then maybe when the Jeopardy game finishes, just quit. So that way you don't have to worry about starting a new game or having 3 more people connecting at the same time. Like I said, we're just trying to make this as simple as possible. Okay. Right. And so if I make another client, you see how this is one thread? So one server thread is handling this, and then the other server thread is handling this guy, but they're sharing the same variable. You see that? Okay. So how many questions? 10 at a minimum. You want to do something cool like have a Jeopardy board, and, X credit. Okay, lots of X credit available. You're worried about your rate. When and where should we submit the Python X credit? That goes on Canvas. So Canvas, and if I disconnect and I reconnect, you can see that even the new thread shares the same variable. So Canvas is where you post these screenshots of thread closed, thread closed. Canvas is where you post the screenshots of you doing Java's in space, and you need to send 2 screenshots in. You need to send in one showing you did everything on the website. A lot of people did like 1 unit and then sent that in. No, you have to do all 5, right? And you get that 5,000 XP. And then the second thing you need to do is send a screenshot of your VS Code development environment up with you having written some Python code that wasn't just copy pasted from the unit. I want to see that you've learned at least enough Python to write a for loop or something like that. Okay. So that's learn a new language, get extra credit. Okay. All right. Any questions about graphs, about Java Jeopardy? Anyone want to partner? Post on the chat channel. Looking for group. Okay, that's it for today, guys. Thank you very much, and have fun with it. Don't let Mulia's bad experience with C++ sockets prejudice you against Java sockets. They're actually it's literally as easy as reading and writing a string to the screen. You can read and write to the network. And so you just have to read it and then do something with it and write something back. Okay. All right. That's it for today, guys. Thank you very much. And I will see you for our last class on Friday. Peace.